Good morning student. Myself Tanam Singh, lecturer electrical engineering, Government Polytechnic College, Mohali, Khunni, Majra. Our today topic is earthing. So, what is the concept of earthing systems? All the people living or working in a residential, commercial and industrial installation, particularly the operator and personnel who are in close operation and contact with electrical system and machinery, should essentially be protected against possible electrifications. To achieve this protection, earthing system of an installation is defined, designed and installed according to the standard requirement. So, to give the protection to the operator and personnel who are working on the machinery or any equipment, to protect that personnel or operator, we done the earthing. So, earthing protect the person from getting electric shock in case of any earth fault occur on the equipment or on machinery. So, student, first we should have to learn what is earthing. The process of connecting metallic bodies of all the electrical apparatus and equipment to a huge mass of earth by a wire having negligible resistance is called earthing. So, you can see in this diagram we taken the case of a faulty toaster. So, in this toaster the earth, if any earth fault occur on this equipment, then this outer metallic body will start conducting the current, and if any operator or personnel touch this faulty toaster, he will get the shock from this toaster. So, to avoid the shock this person, what we have done, we provide earthing to this equipment. So, whenever fault occur, then the faulty current has two paths, that is one from the person and second from the this earth wire. So, as you know, the resistance of earth wire is low. So, the current will follow this path, that is earth wire path, and whenever earth fault occur and whenever current flow through this earth wire, then high current will flow from the line to earth, and the fuse which is connected in the circuit will blow out, and the and the line wire to this faulty toaster will disconnect, and the personnel will be protected from getting the electric shock. So, first thing what is earthing is the process of connecting the metallic body of all the electric apparatus and equipment to huge mass of earth. So, this earth wire is ultimately connected to the earth. This is showing the symbol of earthing, and this is connecting to the earth. So, first definition is connecting the metallic body of all electric apparatus and equipment to the huge mass of earth. We can define earthing in somewhat different way, that is the term earthing means connecting the neutral point of supply system or the non current carrying parts of the electric apparatus to the general mass of earth in such a manner that all time an immediate discharge of electrical energy takes place without danger. So, first we discuss that whenever fault occurs. So, we can define earthing in some different manner, that the neutral wire which act as a returning path for the current is also connected to the earth. So, neutral wire which carries the returning current is also ultimately connected with the earth. So, all the current which is flowing in the circuit is ultimately going to the earth. So, neutral wire is also earth, and earth wire is also earth. Neutral wire provide the return path for the current, and earth wire provide the protection whenever the fault occur on the any apparatus or any equipment. So, next is what is the objectives of the earthing. First objective is provide an alternative path for the fault current to flow, so that it will not endanger the user. So, first you can see in the diagram that this earth wire provide the alternative path in case of fault occur on the earth fault occur on the toaster. So, first objective is to provide an alternative path for the fault current to flow, so that it will not endanger the user. Second is ensure that all the exposed conductive part do not reach a dangerous potentials. It maintains the voltage at any parts of an electrical system at a known value, so as to prevent overcurrent or excessive voltage on the appliance or equipment. So, what is the meaning of good earthing? So, good earthing means simply the earthing having a low impedance, so that it ensure that sufficient current can flow through the safety device, so that it disconnect the supply within a time less than 0.4 second. Fault current is much more than the full load current of the circuit, which melt the fuse, hence the appliance is disconnected automatically from the supply mains. So, what is the meaning of good earthing? That is any earthing system having the low impedance. When impedance is low, then the short circuit current will be high. When the short circuit current will high, then it will blow out the fuse with less time. So, good earthing means that it blow the fuse within a time that is which is less than 0.4 second. So, if time is less, then the equipment, the person will be protected in a very short time. So, good earthing means having low impedance. Next is quality of good earthing. Good earthing must be of low electrical resistance, it must be of good corrosion resistance, it must be able to dissipate high fault current repeatedly. So, good earthing, as we already discussed, that it should have low electrical resistance, and second is it should be good corrosion resistance. Good corrosion resistance means the earthing plates or rod should not be corroded with the moisture, because the plate or rod or electrode is immersed in the earth. So, the material for using earthing should not be corroded, that is it should not be it should not have any effect of the corrosion. Corrosion means jang lagna. It must be able to dissipate high fault current. In case of any in case of fault there will always be high current. So, earthing should be able to dissipate high fault current repeatedly. Purpose of earthing. So, these are the purpose of earthing. First is to save human life from danger of electrical shock or death by blowing a fuse, that is to provide an alternative path for fault current to flow, so that it will not endanger the user. Second, to protect the building, machinery and appliance under fault condition, that is to ensure that all exposed conductive part do not reach the dangerous potential. To provide safe path to dissipate lightning and short circuit current. To provide stable platform for operation of sensitive electronic equipment, that is to maintain the voltage at any part of an electrical system at known value, so as to prevent overcurrent or excessive voltage on the appliance or equipment. So, ultimately the purpose of earthing is to save the human life, building, machinery and appliance, and in case of lightning, dissipate the lightning current, or in case of short circuit, dissipate the short circuit current to the safe path. So that it does not endanger the life of human, or it does it protect the any building, machinery or appliance from getting faulted. Next is electric shock. So, the purpose of earthing is to save the human life from the shock. So, what is the electric shock? An electric shock also named as electrocution, occur when two portions of a person body come in contact with the electric conductor of a circuit which is at different potential, thus producing a potential difference across the body. So, whenever any person come in contact with the two potential, that is come in contact with the electric conductor of circuit which is at two different potential, thus producing a potential difference across the body. As we see in this diagram, that whenever this person come, this is the higher potential and second part of the body is in contact with the earth. So, it will produce the potential difference and current will start flowing through this person. So, whenever whenever a person come in contact with the person body, at two parts of person body come in contact with the two different potential, that is one with the electric circuit and another with the earth, then the person will feel the electric shock. The human body does have resistance, and when the body is connected between the two conductors at different potential, a circuit is formed through the body and current will flow. When the human body comes in contact with only one conductor, a circuit is not formed and nothing happens. When the human body comes in contact with the circuit conductor, no matter what the voltage is, there is the potential for there is no potential for harm. So, whenever the human body comes in contact with only one conductor, and then the person will not feel the shock because the person is not under the potential difference. So, he will not feel any shock if he is in contact with the only one conductor. The higher the potential difference, the more the damage. The effect of an electric shock is a function of what part of body comes in contact with each conductor, the resistance of each contact point of the surface resistance of the body at the contact, as well as other factor. When the electrical contact is such that the circuit path through the body is across the heart, you have the greater potential for death. So, the magnitude of electric shock depend upon the potential difference. Higher the potential difference, higher will the current and higher will the damage. So, the effect of electric shock depends upon the current is passing which part of the body. If it is passing through the heart, then there is greatest potential for the death of the human body. So, it depends upon the which part is subjected to the electric current. As shown in figure, human body resistance vary from as low as 500 ohm to as high as 600,000 ohm. So, the resistance of human body vary from 500 to 60 lakh ohm. As the skin becomes moist, the contact resistance drop. If the skin is moist due to sweat that contain the salt, the resistance drop further. So, as you can see in this figure, the resistance of human bodies vary from 500 to 600 into 10 raised to power 3 ohm. So, the resistance, or you can say impedance of the human body varies from 500 to 600 into 10 raised to power 3 ohms. So, this variation depends upon the skin moisture. If the skin is dry, then resistance will high. If skin is moist, then resistance will lower down. So, higher the moisture content in the skin, higher will be the less will be the resistance. So, when a high voltage such as 800 volt is involved in the body, body is literally cooked at the times of and at the time explodes. So, if the voltage is high, the then the risk when the voltage is high up to the 3 kilovolt, then the person will immediately the body of person immediately cooked, and at a time it will explode. So, the at the 3 kilovolt 13 kilovolt, the potential of electric shock is very much high. The body will literally cooked, and on the spot it will explode. So, here is some data of the effect of the electric current on the human body. So, when we are comparing when current is AC and when current is DC. So, first case is when current is 1 milliampere. In case of AC, if current is 1 milliampere, then this point of level is named as perception level, and at the in case of DC, current is 2 milliampere. So, perception level is at 1 milliampere for AC and 2 milliampere for DC. Second is no let go level. In case of AC 15 milliampere, in case of DC it is 300 milliampere. Next is fibrillation level at 0.2 second. Fibrillation level is a medical terms which means contraction of muscles due to the effect of electric current. So, so fibrillation in 0.2 second. If current is 500 milliampere, then body muscle will contract within a 0.2 second. In case of DC, the current is again 500 milliampere. So, fibrillation level at 0.5 second is 75 milliampere in case of AC and 400 milliampere in case of DC. So, 500 milliampere will cause fibrillations in 0.2 second, and 75 milliampere will cause fibrillation in 0.5 second. So, again I am explaining this what is the fibrillation level. Fibrillation level is whenever person in contact with the electric current, then the body's muscle will contrast with the effect of electric current, and if this fibrillation is related with the heart, then the person will definitely die, or the body will cooked, or it will explode if the voltage is high. So, next is short circuit. To analyze how an electric shock occur and how grounding is applied, you need to look at the circuit involved. So, here the circuit having transformer and 2 resistor and 1 load resistor. So, as you know that the formula of current is I is equal to V upon R. In this case, voltage is E, that is 120 volt, and resistance are connected in series. 3 resistors are connected in series, R1, a load, and again R1. So, total resistance is R1 plus RL plus R1, because this circuit is connected in a series. So, current will be E upon R1 plus RL plus R1. If RL is much greater than R1, then we can simplify this circuit, this expression into I is equal to E upon RL. When short circuit occur, then the line wire will directly connect with the neutral or earth wire without any load. So, whenever this happen, then the current will abruptly rise to high value, which is given by this formula, that is ISC, that is short circuit current is equal to full load current into 100 divided by percent impedance. So, whenever a short circuit fall, the value of current, that is short circuit current, will increase abruptly to a very high value, and if in the circuit no fuse is connected, then this circuit will burst out, and the winding or any electric circuit will burnt out. If fuse is connected in this circuit, then with the high current the fuse will blow out and which will protect the this circuit. So, another is if short circuit may be classified as phase to phase and phase to ground, and in that case the value of current will be equals to E is equal to R1 upon RSC plus RE. E is equal to I is equal to E upon R1 plus RSC plus RE, R1 plus RSC plus R1, because why this RSC not this load RL, because this is the short and current will follow this path rather than this, because this circuit is shorted at this point. In that if RSC or RE is high, the circuit breaker will not open. Low RSC with high RE will cause the fire. So, next is equipment earthing. Again same definition. In case of insulation failure, the primary object of connecting all the above point and apparatus to earth is to release the charge accumulated on them immediately to earth, so that the person coming in contact with may not experience electric shock. Here some data given regarding the maximum value of earth resistance to be achieved. In case of large power station, the maximum value of earth resistance to be achieved is in ohm is 0.5 ohm, 0.5 ohm, major substation it is 1.0 ohm, small substation it is 2.0 ohm, factory substation it is 1.0 ohm, in case of lattice steel tower it is 3.0 ohm. In industrial machines and equipment, the value of maximum value of earth resistance to be achieved in ohm is 0.5. So, the earth resistance depend upon the moisture content in the soil. This line will we will explain in detail in preceding slides. So, remember this line, the earth resistance depends upon the moisture content in the soil. Method of earthing. Earthing can be done in two ways: conventional earthing, maintenance free earthing. Conventional earthing, the conventional system of earthing calls for digging of large pit into which a GI pipe or copper plate is positioned in the middle layer of charcoal and salt. It requires maintenance and pouring of water at regular interval. This is the diagram of conventional earthing. The earthing rod is inserted in the earth and the outer layer is covered with charcoal and salt. What is the purpose of charcoal and salt? Is to improve the soil conditions. This will be we will discuss in the preceding slides. Maintenance free earthing, it is new type of earthing system which is ready made, standardized and scientifically developed. Its benefits are maintenance free, no need to pour water at regular interval except in sandy soil, consistency, maintain stable and consistent earth resistance around the year, more surface area. The conductive compound creates a conductive zone which provides the increased surface area for peak current dissipations. So, important slides are method of conventional earthing. Conventional earthing are classified in following 5 types, that is plate earthing, pipe earthing, rod earthing, strip earthing and earthing through water mains. So, first is plate earthing. In this type of earthing, plates either of copper or of GI is buried into ground at the depth of not less than 3 meter from the ground. The earth plate is embedded in the alternative layer of coke and salt for minimum thickness of about 15 centimeter. The earth wire, copper wire for copper plate earthing, and GI wire for GI plate earthing is securely bolted to an earth plate with the help of bolt, nut and washer made of copper in case of copper plate and GI in case of GI plate earthing. So, here is the diagram. For plate earthing, either a copper plate or GI plate uh, is buried in the ground at the length of 3 meter. If this plate is made of copper, then the earth wire used should be made of copper, and if this plate made up of GI, then that is galvanized iron, then this earthing wire should be made up of GI. So, let discuss this diagram. This is the diagram of plate earthing for the purpose of earthing. This center part, this is the plate made up of GI, that is galvanized iron or copper. This one is earth wire, which connect the circuit to the earthing. Here is the wire mesh or funnel. This is used to pour the water into the to pour the water to moist this earth plate surrounding. So, this is the mixture of coke, that is charcoal and salt. What is the purpose of this charcoal and salt? Is to maintain the moisture content of earth and improve the quality of soil around the earth, because the earthing depends upon the moisture content present in the earth around the plate. So, we use the charcoal and salt to maintain the moisture content around the plate. Next is pipe earthing. Pipe earthing is best form of earthing and it is cheap. Also in this system of earthing, a GI pipe of 38 mm diameter and 2 meter length is embedded vertically in ground to work as earth electrode, but the depth depends upon the soil condition. There is no hard and fast rule for this, but the wire is embedded up to the wet soil. The earth wire are fastened to the top section of the pipe with nut and bolt. The pit area around the GI pipe filled with salt and coal mixture for improving the soil condition and efficiency of earthing system. As we discussed, this charcoal and salt is used to improve the soil condition and efficiency of earthing system. So, with the purpose of charcoal, coke and salt layer is to increase the moisture content around this earthing plate. The earth wire connection with GI pipe being above the ground level can be checked for carrying out continuity test as and when desired, while in plate earthing it is difficult. So, in pipe earthing, GI pipe is inserted and around the GI pipe mixture of charcoal and salt, layer of charcoal and salt is immersed. The purpose of this charcoal and salt layer is to improve the soil condition and improve the efficiency of earthing. So, if you use the material for this pipe earthing copper, then all the nut and bolt and connector should be made and earth wire should be made of GI. If you use the material for this pipe for earthing, copper, then all the nut and bolt and earthing wire and the earthing connector should be made up of copper. If you compare plate and pipe earthing, then pipe earthing has advantage over the plate earthing, that it can take heavy leakage current for the same electrode size. First, it can take heavy leakage current for the same electrode size. Second,